what we're being asked to find here is a list of all the possible zeros for this function. And they're not giving us any zeros to start with, so we're just listing them from scratch. The way that you make a list of the possible zeros is using something called the rational zero theorem, which is a little formula that's going to help us list all of these possible zeros. So the formula is P over Q. That's it, but you have to know what P and Q are talking about. So P, for any polynomial here, stands for factors of the constant term, factors of the constant, over Q, which in any polynomial stands for factors of the leading coefficient. And we know that the leading coefficient is the number that comes in front of the first term, right? So for this polynomial, when we set up all of our fractions, P over Q, our P is going to include any factors of the constant term, which is 12 here. The constant term is the one that has no x next to it. So all the factors of 12 have to go on the top of our fraction. Now the factors of 12 include like 1 and 12, and 2 and 6, and 3 and 4, right? But could also include -1 and -12, or -2 and -6. So we have to make sure that we just put plus minus in front of all of our factors. So the top of my fraction is going to include a bunch of possibilities. Plus or minus 1, 2, 3, and 4, 6, and 12. And those are all of the possible factors of 12, right? Now on the bottom, it's going to be much easier for this one, because the leading coefficient is just a 1. And the factors of 1 just include plus or minus 1. All right? So believe it or not, you filled in the formula. Now all we have to do here is make a simplified list. A simplified list of all these fractions. So the simplified list is going to include each one of the numbers on top over the numbers on bottom. And since there's only one number on the bottom, we'll have a nice little list to write here. Positive or -1 over positive or -1 is positive or -1, followed by positive or -2 over positive or -1. And since 2 over 1 is just 2, we add plus or minus 2 to the list, and so on and so forth. So our simplified list here is just going to include all the same numbers from the top of the fraction. It's not always going to be this easy. For our first example, it's nice to have 1 on the bottom. So there is a simplified list of all of our possible zeros for this function. And if I wanted you to actually get the zeros, well then you would have to go through that list and use synthetic division to figure out which one works. Let's try another example where we're just writing a list. So we're asked to find the list here of all the possible zeros for this function. Again, they're not giving us any to start with. We're finding it from scratch. So we're going to set up P over Q. And remember here that P are the factors of the constant term, which here is 10. The factors of 10 include plus or minus 1, 2, 5, and 10, right? Those are all the factors of 10. Over, this time, our leading coefficient is 4. So the bottom of our fraction will include more than just 1. The bottom of the fraction will include the factors of 4, which are 1, 2, and 4. All right, so there's our possibilities for the tops and the bottoms of these fractions. And now we have to make our simplified list. So here's an example where it's just a little bit more complicated to write our simplified list. First on the list is going to be 1 over 1, which is 1. Then we'll do 2 over 1, and we'll just keep 1 as our denominator for now. Then we'll deal with the other denominators. Then we have 5 over 1, so plus or minus 5. And we have 10 over 1, which is plus or minus 10. But our list can't stop there. I'm going to change colors now so you can see instead of going over 1, now we'll go over 2, which is our next denominator here. So we'll do positive or negative 1 over 2, which is a half. Then we will do positive or negative 2 over 2. Now 2 over 2 simplifies to just the number 1. And since we already have the number 1 on our list, I'm not going to put it on the list again. All right? Moving on, we have 5 over 2. 5 over 2 is not on our list yet, so we will have to put it 5 over 2. And then we have 10 over 2. Now 10 over 2 reduces to just the number 5, and since we already have 5 on the list here, we will not write it again. All right, so now we've done all of the fractions that have 2 as the denominator. And now let's do 4 as our denominator. So positive or negative 1 over 4. We do not have that yet on our list, so we will write plus or minus 1 over 4. 2 over 4. Now 2 over 4 is the same as saying 1 over 2, which we already have on the list over here, so we will not write it again. Then we move on to 5 over 4, which is not on our list, so we will put comma plus minus 5 over 4. And then we have 10 over 4, and if you put 10 over 4, you should know that that reduces to 5 over 2, and we already have 5 over 2 on the list, so we won't put that on the list. Again, once you've done all that, then you have your complete list of all of the possible rational zeros for this function. Numbers 3 and 4 on your homework ask you to go a step further and actually find the zeros. So now you have to use your list and actually figure out which one of those zeros on your list works for this function. So for starters, we need to make our list of P over Q so that we know what numbers we're going to test. P for this, factors of 20. So the factors of 20 include plus or minus 1, 2, 4, 5, 10, and 20. And Q for this function are the factors of 1 again, so just plus or minus 1. So our simplified list is going to just be all of the numbers on top over 1. So nice whole numbers. We don't have to do any fractions. 5, 10, and 20. All right, so how do we figure out which one of these actually works? Or which 2 of these or which 3 of these actually work in the function? We need to use synthetic division, and what we're hoping to get is a remainder of 0. If we get a remainder of 0 when we do synthetic, that means the number we picked is one of the answers, all right? So let's just hope that we get lucky on our first guess, and you can pick any number off this list to start with. I'm going to start by testing positive 1. The first thing on my list, and number 1 is really easy to deal with. So I'm going to put positive 1 in my little box and set up synthetic division. My coefficients are 1, then negative 8, then 11, and then 20. And this is why it's helpful to be very good and very fast at synthetic. We'll bring down 1, and then multiply, add, and then multiply, add, and then multiply, and then add. Now I got 24 here. That's not a 0, and I wanted it to be a 0. So since this one doesn't work, I'm going to erase it. I will leave my coefficients there, and I'm going to put something else in the box, knowing that positive 1 did not work, so I'm crossing it off my list. Rather than trying negative 1 next, I'm going to get a little creative here and just try, I don't know, positive 4, just to see how it looks. Maybe I'll get lucky and positive 4 will work, okay? Synthetic division, bring down the 1, then multiply, then add, then multiply, then add, then multiply, and sure enough, 20 and negative 20 adds up to 0. So positive 4, the number that I tested here in my synthetic division, is one of the zeros for this function. So I'm going to write that over here. X equals positive 4 is one of my answers, so I don't forget that it's there. Okay? Now I have a couple of options. I could go ahead and keep using synthetic division and just guess and guess and guess and guess until I get the other ones that work. Or, and this is a much better option, you should write your depressed polynomial and see if you can factor it. So our depressed polynomial, if we started out as x to the third, is now x squared minus 4x minus 5, and it has no remainder there. And we want to look at that trinomial and see if we can factor it. We're looking for numbers that multiply to make negative 5 that add up to negative 4. So you should be able to figure out that what you're looking for is minus 5 and plus 1. which means you can see what your other zeros are without having to use guess and check. You should be able to see now that your other zeros are x equals, if you solve this one, it would be -1, right? Let's put that one in a box as well. And if you solve this one, then x would equal +5. And now both of those numbers were on the list, so you would have gotten to them eventually, but rather than wasting time using guess and check, we just used our factoring skills to get the other two answered, okay? And sure enough, we ended up with 1, 2, 3 answers for x, which is what we expected because this function was x to the 3rd power, okay? And that's how you'll do numbers 3 and 4 off your homework.